let's get started. This is, again, CSE 519. We're going to have the second Python lecture today, which is going to be on, more machine learning-y and higher level things than what we had talked about before. But before I turn the students loose on this, I'd like to do a quick check of discussion about the homework. How many people have started on the homework? Is there any twitching at all? I am seeing no twitching. Any questions about the homework? Any interesting observations or anything like that about the homework, if anybody played with the data?
Yeah, I actually found something interesting. I was wondering if anybody else found it. So when we were doing the analysis of the highest revenue shops, I think that's in task 3, it seems like the two the two highest revenue shops only made sales for the period of 1 or 2 months, and then just kind of fell off the face of the earth, or at least as far as the data set is concerned.
Okay. Did anybody else notice such things? Okay, not sure if I'm seeing twitching or, again, that might very well be true, okay? It's possible, I wonder, so one thing is they may not have given us the entire data set for the entire company. Was there a period of time over which those stores were open?
It's not obvious from the data set. The only thing that really made it stand out is that the revenue that the total revenue that these 2 stores generated in the period of 2 months was was greater than the total revenue over 3 years for the next highest store. So I was just kind of confused. Something to note was that it was, I think, a French store was the translation, so maybe that has something to do with it. But
I am seeing different results, actually.
Okay. Say that again. Speak louder.
Saying, can you hear me now?
Yeah.
So I am saying, I was seeing different results.
How different?
So I just checked for the topmost shop, which was translated to something called Moscow TC Semenovsky, and it was not like it's kind of uniformly distributed. Not
I think Nico's talking about revenue, not sales.
Total revenue, yeah.
Yeah.
The CDs. Oh, okay.
Revenue. So how? Okay. So I'm calculating the revenue by multiplying the item count to its price.
Item count to its price. Okay.
That will give you the total sales value. I mean, according to me.
Oh,
No, yeah, I agree.
So
I'm pulling up my chart now to see.
Okay. Now I heard you say something about the store in Paris being different. Is it different that again I don't look at these things, but were all the stores in Russia except for those?
Yeah, as far as I could tell.
Is there, again, we'll talk about cleaning at some point. Is there possibly some issues about currency conversions?
It's possible.
Oh.
Okay. Again, I don't know. I recognize I don't know anything, but but it's interesting to kind of view in a data set as to why something is. Actually, do both of you agree that the highest revenue store is as Nico said?
Which one was yours, Nico?
So do you want, I can't say the Russian version, so I'm gonna have to translate. It doesn't even translate good. So it's something 56 francs.
No, for me it translated to Moscow TC Semenovsky.
Moscow TC. That looks like the one I have as third. Let me check. No. I think, okay, maybe, okay.
I might encourage you to continue this discussion on the piazza. I think this is a noble place to have this kind of discussion, unless there are reasons why this is happening, okay, that someone finds that are interesting. Any other questions about, so of course, bugs are not interesting. I don't know if either of them are bugs, okay? But an observation like that is interesting and requires some kind of an explanation. I mean, just in life. I'm not talking about for the homework assignment particularly. And, you know, without looking at the data, could it possibly be true? If it's stores that pop up for Christmas, maybe there's something different. Or if it's in a different country and they're measuring in a different currency, maybe that is something different. Or maybe there's something else. I don't know. If the stores sold different merchandise, if one of them was a jewelry store and the other one sold paper clips, that would be a difference, okay? So I don't know, again, but it may very well be that that's something one should understand to the point of, having a theory as to why that is. Any other questions? Any other questions or comments about the homework?
Here, Professor. I'm wondering, I'm doing linear regression on the data and on normalization. I read two methods. One is mapped to 0 to 1. Another is mapped to -1 to 1. So what do you suggest we do?
Okay, so what you're saying is you have variables that you are trying to map to, you would like to take numerical values. Well, actually, they're numerical values, right?
Right, right.
And you would like to, instead of treating them as raw numbers, you might want to map them to something else by something like, let's say, z-scores or some other method of normalization. And you're asking me, which is the better range? From
right.
0 to 1 or -1 to 1? Is that what you're saying?
Yes, yes. Since we are trying to predict a sale.
Okay, again, we will talk about some of these things later on. Now, my immediate thing is in a linear regression, you are multiplying by ultimately trying to find a coefficient to multiply this number by, and add it to something. And the difference between the spread of a value from -1 to 1 and a spread from 0 to 1 is not that large. So I doubt that the spread here is going to make a difference, okay? But you may want to look at what the right, again, when we talk about normalization, we'll talk about it later on. Are you mapping, what values are you trying to normalize? Just to give me an idea.
Like two different values, like there is
what's the name of the variable?
The sale price and the data, the days, how many days it has been released.
Okay, so sales price, there is, that may run over a long period of time. There, depending upon what's in the store, it may be you want some kind of nonlinear normalization. If people were buying, antiques, if people were buying paintings by Picasso in this store and also buying paper clips, okay, it might very well be something that you would do in a nonlinear way, although that's probably overkill right now. Bottom line for your question is, I would say try whatever. I don't think what you're doing, whether you normalize it to a range of -1 to 1 or 0 to 1, necessarily makes any difference as far as linear regression goes. So I might encourage you to try both of them and see if it makes any difference. Okay?
All right.
But I would also say that it probably pays to keep variables explanatory. So when you were telling me something about like the range of how long has it been in the store, -1 doesn't mean very much to me. Okay? There I expect dates to be kind of positive numbers. Okay? And it might be easier to interpret it something like that. Okay? When I think about something that has a bell-shaped distribution, I think of something that's centered around 0 makes sense. And normalizing that to be centered around 0 might make sense. But for those of you who are listening, don't listen to too much to what I'm saying too deeply. I encourage you to keep the philosophy of KISS, keep it simple. Try to build your models first as simply as you can. And then later on, you can try to play with things and see how it changes. Okay? The wrong thing to do is to say, oh, I'm going to hyper normalize every single variable and do some kind of magic and then run one regression and that's the answer. A better thing might be to try to do a couple of different simple things, see how they perform. Then modify certain things and see how it affects it. Does that make sense?
By simple things, you mean, I kind of think linear regression is the simplest.
Okay, but the simplest thing would be to not normalize anything.
Oh.
Do we agree that not normalizing anything is simpler than normalizing it, right?
Yes.
Okay, so that might be an argument that the first thing I'd try would be something very simple. And I'd see what happens. And then I might think a little bit more about normalize, which can have an effect depending upon the range of things, depending upon how things are plotted, how things are distributed, okay? But I might first try doing something simple without normalization and then see, okay? Does that make sense? Philosophically, how I would be thinking about this?
Yes, it do. But
okay.
Without normalization, the regression kind of goes a long way.
Okay, if you're telling me that without normalization, the regression does bad things, then that's a sign that when you then did some regression, that when you did some normalization, it would do better things and you would see it do better things. Okay?
Right.
So I encourage some experimentation here. And again, exactly why, again, we'll talk a little bit more. Next class, we'll talk more about data cleaning, and that's an appropriate time to talk about this. Okay? Any other questions?
I had a quick question on autocorrelation.
Yeah.
So there was a question in the quiz about the amount of rainfall and the daylight in a day, amount of daylight in a day. But I did not understand why rainfall is not autocorrelated and sunlight is autocorrelated.
Okay, so first of all, we will not, whatever answers are given on the quiz, those are good enough for grading the quiz. So this is now an intellectual question and not a grading question.
No, it's not a grading question.
Intellectual question. Now, what I would say is, do we think that the amount of rainfall is autocorrelated? And I would imagine that rainfall, well, first of all, let's think about sunlight. I would imagine the sunlight is very autocorrelated, okay? In that the amount of sun, the number of hours of sun I'm going to get today is going to be exactly how many hours of sun I'm going to be getting a year from now. In terms of the official number of hours from sunrise to sunset, right? So do I believe that that you would have a strong autocorrelation in the amount of sun on an annual basis? The answer is yes. My guess is the amount of rain each day. If I was thinking about this, let's say on an annual basis, is there going to be a spike at 365? Whether it rains today probably doesn't tell me all that much about whether it rains 365 days from now. Okay, rain is a more intermittent thing. Okay.
Okay, I think I got that wrong. So autocorrelated is when It is
when there is a periodicity in the data.
Okay.
Okay. That's kind of what I would think an autocorrelation is.
Okay, got it.
Any other questions? Any other discussion that people would like to have? Okay, if not, I would like to turn our attention again to the team imported from my lab, Charuta and Fahad. They were here a week or two ago talking about an introductory Python lecture. I'd like them to go through some of the more advanced libraries about things like machine learning and stuff. And so I now turn the television over to them.
Can you see my screen?
Yeah.
Okay. So this is where we left off last time. We had a data set of TED Talks telling us the number of comments, the duration in seconds, the number of languages it was released in, and so on. And we went through some Pandas basics and Python basics as to how to manipulate data. And we ended at plotting histograms, column-wise histograms of every column in the data. And so just to go over this once again, this is a basic example of how you can use matplotlib. So here we're defining just a simple list of numbers. Here we're using list comprehension. So for every element in this list, we're taking x times x. The same for q. So we could also replace this with x star star 3, which is the same as x cubed. And calling plt.plot multiple times before saying plt.show adds the two lines to the same plot. Any questions about this part here? So the semicolons here are just to suppress the matplotlib function return outputs. We can move on. So here we're plotting basically the same graph again, but we're customizing it a bit with matplotlib custom functions. So here we're specifying that we want the figure size to be height and width 4. Here the dash s specifies that we want it to be, we want the points to be denoted by squares, as you can see in the green line. And we can also specify the color per line. So a dash dot means you want a dotted dashed line for that. You can also specify which ticks you want to show. For instance, here we could see the in our X array we had only the numbers 1, 2, 3, and 4, but we were seeing unnecessary additional ticks in here. If you specify X ticks and give an array as an argument, it will restrict the ticks on the X-axis, and the same goes for Y-axis. And one additional thing here is we're calling plt.grid just for better visibility, and here you can specify axis as well. This just restricts the lines to horizontal ones to make the y-axis more readable.
Okay, what's wrong with that graph? The answer is it is super boring. Okay, in general, we want to make interesting graphs. Okay, and that really tell us something about the data. Okay, any questions about that? Let's move on.
Okay. So this is where we actually left off last time. We were talking about correlations. So when you call, let's just recall what the TED mean data frame looks like. So the head function returns the first n rows of the data frame. So we have the number of comments, description of the TED talk, and a bunch of other features about every TED talk. So when we call the .corr, the correlation function, it returns a table of correlations between all the numeric columns in the data frame. So in here, it got rid of the columns which we had in string form, like description and name, and we just have the subset that have numeric values. So to make it easier to visualize, we're going to use Seaborn to plot.
Let's just take a quick look. Just sorry to be a nudge. Do these correlations make sense? Okay. So for example, what do you remember what languages means?
It's the number of languages in which the talk is available.
And we see the number of languages it's in, it correlates inversely with the length of the talk. That's interesting. Why do we think that is? I don't know. Is there a reason?
It might be that it's easier to translate.
That's what I think. People, they're too lazy to translate long talks, but they are willing to translate short talks. Okay.
Yep. It also translates into more number of comments and more views so it might attract viewers from different languages as well.
Right, so if you look at this thing, the number of views correlates with the languages. They want to translate talks that have a lot of views because they are popular. They're probably the better talks. And on the other hand, they don't want to translate long talks because it's a lot of work. Okay, any questions?
Another intuitive thing here is comments and views are very highly correlated as well.
So if people watch, they chat, right? Yeah. And the people who don't watch don't chat. Okay, good.
Yep. So just to make this visualization a bit more intuitive, if we use Seaborn's inbuilt heat map function, this converts all these values into a scale of 0 to 1 based on the scale you can see on the right. It's still not easy enough to read, so we can specify custom attributes of our own. So for example, since correlation is going to be from -1 to 1, we can specify the min and max for this scale. And we wouldn't want it to go from black to white. Instead, we'd want a medium color in the middle and then two extremes on the top and bottom. So this inbuilt color map specifies that with red and blue. Just to make it a bit prettier, we can specify how much distance we want between two different cells and whether or not we want to print these values inside these cells.
So this color scheme is a lot more informative because red presumably is positive, the other one is negative. It kind of does, kind of show off what the correlations are in a more meaningful way. So I like that.
We can define our own color maps in here as well in case we don't want red and blue, we want red or green or something else instead. But yeah, this is the basic SNS heat map function. Other than that, so earlier what we did was we called .hist on the entire TED mean data frame, but we can call this individually on single columns as well. And when we do that, we can specify how many bars we want in this plot. So this is probably not very informative. If we increase this, it becomes a bit more helpful. Any questions about this? So this is something that usually ends up happening if the the histogram looks something like this. It's helpful to plot it on a log scale. So we're simply calling the numpy log function here and then calling the histogram function after that. So this shows that the log number of comments is normally distributed.
That's interesting. Now, one other thing, if you were making a plot like that, you might want to, is there a way that instead of taking the log of this, you plotted it in log, did a log plot? So the y-axis was the real numbers of comments, but on a log space?
Yes, I think so. They have, the .hist function has a argument that you can specify that tells you whether you want a log scale or not. Just log. Yeah.
Okay. All right, the y-axis here was the log, what is in log space, not the x-axis. Okay, fair enough.
We've done the same for a few other columns. This is for duration and number of seconds. Okay. So this is where the machine learning part starts. So here what we're going to try to do is predict the speaker's profession from the label that's given to the talk. So what we're doing here is, since we have a lot of professions within this data frame, let's see how many there are. Yeah, there's 1450 different professions. So we just want to stick to the most popular ones, and we're just going to put everything else into other. So we're using the top 500 in here, and so we're applying a lambda function here again. So for every row inside this data frame, if the occupation is within the top 500, it stays the same. Otherwise, we just label it as other. So this is what.
So how many are there now after you've done that? How many of them are there in each one of these professions?
I go one. Since we restricted to the top 500, it's that many plus one for other.
I see. So other is now the most important one.
Yep.
Okay, fair enough.
We could restrict this to, I guess, 50 as well, just to make it more informative. Yeah, these make more sense because now we have musician, singer, comedian instead of random things which have only one row in them. Yep. So this function is something that does one-hot encoding on these, which basically means it turns it into a matrix of zeros and ones where, let me show you an example. So in here, we have one row corresponding to every value that this column can have. And so for example, for row one, if it's other, the value corresponding to other will be one and everything else will be zero.
Okay, are there, sorry. Any questions from anyone about this? I don't know if people are into what's going on yet. So you're saying that in order to do this classification, you're thinking that you'd like to, instead of predict, you'd like to make this a matrix so that each person it has a vector of what their professions are, a bit vector of that, correct?
Mm-hmm.
Okay, and that's what they have done here with these one-hot vectors.
Yeah.
So you're still working with trained data, right? If I'm understanding it correctly.
Yep, this is still training data.
Okay.
So the splitting comes next. So we're going to use these as inputs, and then we're going to try to predict the tag of the talk given the occupation of the speaker. So this data frame that we just generated is our input. We're going to call it X, and what we want to predict is, let's take a look at what the Y column looks like. So we're going to predict whether or not the talk is related to technology. So here also we're applying a lambda function that just checks whether the word technology is in each of these lists. So that's everything up to here. And then for this, we're going to use an inbuilt sklearn function. This basically, when you give it an X and a Y and a number that tells us the percentage of split that you want for test versus train, it returns 4 or n different outputs depending on what you give as input here. So since we have just 2 variables X and Y here, we're getting 4 variables as output here. Any questions about this?
Again, we haven't talked about machine learning in here at all and what this deal is. Normally, when you're training a classifier, you want to separate your test data, your evaluation data from your training data to make sure you don't overfit. How is it that Kaggle is going to make sure you don't overfit when you try to submit it?
It probably has its own test data too.
They have their hidden data. When they have their leaderboard, they are not showing you the data that they are running on their actual final evaluation on. Okay. Obviously, if you knew what the final answers were, people would write programs that were customized for just that. Okay. And but when you're training your own business, you have to do that kind of a split. And that's what this is, the machinery she's talking about is. And on your problems to evaluate how good yours is, okay, when you're doing your regression, it probably pays to split the thing up into a test set and a training set. So you know whether your regression really is any good. Okay, so this is not an unreasonable thing to want to do. Keep going. Unless if there's any questions.
So we already have a test set, but we're dividing the train set into 70-30, right? I don't understand that part.
So we're just using everything from the TEDmean data set, applying one-hot encoding and this lambda function here, and we're splitting that into train and test.
Yeah, but don't we have like a different CSV, which is like for test?
In this case, we don't. For Kaggle challenges, usually there is a separate test file that they have, but in this case, we are just creating our own test set.
Right. So, okay. Okay.
So you should know how well you're doing before you submit it to Kaggle. Okay. The wrong thing is to try to overfit on your data set and then think it's going to perform well on theirs. If you take the data set, the data that they have given you, and you split it into some for training and some for testing, you will have an honest opinion of how good your model is. Okay, and that might help you make a better model before you submit it to Kaggle.
So with our homework too, we can do the same thing where we can split the split our training set into 70-30 or.
If you wish, yes, it might not be a bad idea.
Right.
So a couple of things before you actually move on to the machine learning model are usually helpful. Just checking out how big your train and test sets are. This is giving us an idea of the split here. And the same goes for class balance. So the tag that we're trying to predict is whether the talk is technology related or not. So from our total data set, we have 723 talks with the technology tag in them and about 1800 with technology not in them. So it's a bit imbalanced, but it's good to know this before you try to train any models for prediction. So here we have a demo of just how to use logistic regression ready-made from sklearn's library for fitting a classifier and predicting on values from the test set. So here we are creating an object called logistic regression of that class. When we say dot fit, we're training the model using our X and Y from the training set. And this line here is using the trained classifier to predict Y values on rows in the test data. So we can take a look at what the predictions look like. It will basically be a row of Booleans. So this will be of length X test, and we have a prediction for every row in our test set.
So again, on your homework, the problem is one of where you're trying to predict sales. That's a number. And for that, you use a technique called linear regression. For this particular example, what you're trying to predict a class, is it a member of a technology talk or not? There is an extension of linear regression called logistic regression. And that's why she wants to get a true or false answer, okay, where you want to get a numerical answer, okay? Any questions about that?
Okay. So this is also a helpful tip. If you're not sure what exactly a function does, you could just put a question mark in front of it and execute that cell. So a help window shows up, which tells you what exactly all of these parameters are. So here we're calling it with the actual test values and the predicted values from our model. And this is returning the accuracy of the model directly. So in this case, it turns out that predicting the label of the talk from, or whether the talk is a technology talk or not from the speaker's occupation is a pretty good predictor. We have the 74% accuracy. In case we want other metrics apart from accuracy, like class-wise distribution as to how it's doing on technology talks versus non-technology talks, this is another handy function. It's called classification report. So it gives a class-wise split and the global average values for our predictions.
Where can we, so can we get, do we have access to this Colab file that you're working on?
Yep.
Okay, is it on the website?
It should be there in the part 1 link on the website.
Okay.
Where is it?
I can paste the link in this Zoom call as well.
Send the link on the Zoom call.
Thank you.
Actually, they don't have questions.
Now, just to look at this thing, if we look at her classification report, and again, you guys are not doing classification yet, but you will. It looks like one of these classes, it's much more accurate when you make that, when you call something to be true. And it is true. That seems to be a lot more accurate, but you don't do it as much. That's what the precision and recall is. Is true the smaller class?
In this case, yes, true is smaller.
So this is one where you had two classes, one big and one small. If I wanted to decide who in here was a person versus a Martian, almost all the members of my class are people, okay? So I would probably have one class that was much bigger than the other. If I decided to call someone a Martian, they had better be the classifier is going to have to be really sure they're a Martian in order to make that call. And that's why you see a phenomenon like this, okay? Very few things are being called the small class. That's why the recall is small for true. But when we do call it, we're getting it right. That's kind of what you're saying. And this we will talk about more later, so don't let me confuse you. Okay, keep going, I'm sorry.
This is just another template code. So in this case, we'd use logistic regression. There are other ready-to-use classifier modules available as well. So here we're trying to compare logistic regression with decision tree. So you can use either of these or any other kind of classifier. All of them mostly are available in sklearn. You could use SVMs, or you could build a model of your own as well with just a small neural network with a multilinear perceptron. The template code would be the same, just this class name would be different. So you would define your object here, fit it to training data, and get predictions using the .predict function.
So we are looking for something like some sort of a regression which gives you a numerical value, not classification in our case. Right?
Yep,
so,
we will be covering that next with a different data set.
Okay, perfect.
I guess that's it. Yeah, Fahad is going to continue.
Okay, can you hear me, guys? Yes. Okay, so we're going to discuss machine learning a little more detail. I've copy pasted a link to another Colab file which I'll be using. Let me share my screen. Okay. So we're going to use a different data set. This is a data set collected from a subreddit called Dank Memes. We got the initial version of it from Kaggle. The link is here down below. We're just going to read in this data set and have a look at what is in here. Okay, how do I hide this a little bit? Zoom video is in front of my Colab. So we're just drawing out like 3 sample rows to get a sense of what kind of fields we have available in this data set, and you can see what we're basically working with here is, let me just run this again. We've got the author, the guy who posted the meme, we've got the actual image, we've got number of downvotes, we've got the title, we've got the date on which it was created, the dimensions of the image, the thumbnail, and the number of upvotes, which arguably is the most interesting field in this data set. And we have an identifier for the post. So this is the new data set that we'll be working with to discuss some of the other ideas that we cover. So let's just for exploration, let's plot the distribution of the upvotes in this data set. This is kind of what it looks like. I think Charulata showed a similar distribution, and this is a distribution that you would come across a lot when working with real-world data sets. It's called the power law distribution. And in this case, what it's basically showing is that there are a very few number of posts that are disproportionately more popular than the average post, which tend to not do so well. So this distribution, as you can see, has a
what you're saying is here that the reason why there is all that blank space on the right of this plot is there is presumably some meme that got 300,000 upvotes. But it because it's such a small number, you don't actually see the dot. Is that kind of what you're saying?
Yeah, because the y-axis here tells you the number of posts that have the value on the x-axis, and on the x-axis we have the number of upvotes. It just so happens that the number of posts that have, for instance, 300,000 upvotes are so few that you can't really see them when compared to most of the posts, which are way down towards the left of the x-axis. Any confusion?
A quick question. Do we have a method to zoom in this graph?
I think you can do something which I'll try it. I think something like this. Let me see. I mean, Charlotte can help me out with it. You can think of something.
Yeah, this usually works. The only issue with this might be that once you zoom in, the bars might be too thick. In that case, you would need to change the number of bins, and then it would work out.
Yeah, I mean, if you just want to visualize it, I guess what I can do is.
I think you need to change the Y lim too once you change the X, and that's why it's not showing.
Sort index, I guess.
What is the max?
So the max is 29,000.
Okay, so there is something there, but you're still not seeing it, right?
Right.
So if you wanted to zoom in, you would set the X limit to, I guess, 18,000 onwards, and then the Y lim would be 0 to 5, and that would show up as a bar of height 1.
Yeah, he didn't change the Y limit. Yeah, the Y limit.
In this case, is a bar plot what we want? Would something different be better? If we want to see outliers.
All right, so if we look at this and stop, if we look at that now, does that look like an exciting plot? Okay. Right. Does that look like an exciting plot? Okay, I'm going to say probably not. Okay, but it shows that there was data there that you weren't seeing. How might you make that a more exciting plot? Can you plot the y-axis? Show me the whole range, but plot the y-axis on a log scale. And I'm sorry, I'm asking you to do this on demand, programming on demand, but.
Yes, so actually, Charulata covered this.
Okay, bingo, stop. Now, is this a more interesting plot? Okay, now you see it out there, right? Now, where is that outlier? Now you see the outlier. Okay, you see what the frequencies are. Does everybody see that this is a more interesting plot? Because it is on log scale. Some of you may say, wait, but I don't know what 10 to the 3 is. Is there a way to make the y-axis not a exponent? Probably is. Okay, there's always.
Yeah, we can set the y-ticks to have these like the positions of these, but labels to be different.
Okay. For the purposes, did everybody see how the log scale showed the thing that was more interesting? Okay, here, because it was a power to law distributed variable. And we will talk more about such things later on. Move on. Sorry about that.
Okay, so again, just to cover how we did this, we just added this log parameter to the histogram function that comes with matplotlib, and that just automatically logs the y-axis. And if you want to impose any constraints as per the initial question, you can just use, again, functions of matplotlib called xlimit and ylimit, like we've done it here. And I'm going to leave them commented so you can play around with it yourself. But the problem, okay, so just moving along, the problem with this data set when we initially got it from Kaggle was there aren't really many interesting fields here that we can try and predict using the other features. The only one that's interesting is the number of upvotes. And this is something that you'd come across a lot, especially in your projects where you might have a data set that you'd be interested in working with, but you would not have interesting fields. So what you would often find yourself doing is actually going out there on the internet and scraping the relevant fields that you want. So, and that is exactly what we did here. To add more interesting fields to the data set we got from Kaggle, we actually scraped ourselves the subreddit dank memes on from Reddit. And here's a piece of code. I'm not going to go into this. You can go over it yourself, or you can reach out to us if you feel like you need some help with this code. It's straightforward. It's relatively straightforward and it's useful. So I'm going to leave it here in this Colab file for you to revisit at some point. But after this scraping of Reddit, I'll show you what other fields we collected.
Just to mention it quickly, we've used Beautiful Soup here. That's a library that helps you parse out text from HTML and obtain relevant fields from web pages that you might be interested in.
Right. And we've actually used another, just for completion, another more advanced library, I would say, called Selenium, which works well for websites that have what is called lazy loading, where the content is dynamically loaded. But if it's a static website, Beautiful Soup should suffice for your scraping needs. So after the scraping, we collected like additional data fields. So as you can see, the ones that are on display right now we had already, but the additional fields we have are comments. So we actually went out there and we collected the comments that were posted on each post on this subreddit. And we also have these meta variables called total number of comments and total number of upvotes. And so any questions about this data set that you might have? So, and so we did this because previously we only had one interesting variable, which was the number of upvotes. But now we've got two additional ones called total comments and the number of upvotes.
What are you trying to predict?
So I'll talk about that. What we'll be trying to predict is, so in this subreddit, the joke is each meme is rated as either being dank, which is like, it was like good, or not. So that is what we are initially going to try and predict. And the way it's labeled, that I'll cover that in a bit. Because so this data set is a little messy, so we'll do a little bit of pre-processing. And this is basically, we do all the pre-processing in one line. We're using, again, apply with Lambda functions. So the way, I was going to cover this. The way a post on this subreddit is classified as dank or not is there is a bot that Reddit, the website, has, which posts a comment. If it gets enough engagement and enough upvotes, it posts the comment, this bot, which just says dank. So that we're going to use that comment as our y variable here. And so what we're doing in this pre-processing steps are we are putting all the comments together for a post into one document. So previously each comment was a single line. We're concatenating them by just adding spaces in between, and we're sort of removing this y variable which we want to actually predict, so that it's not we're not cheating. And some other, again, we're adding this variable which is going to serve as the y variable, and we set it to true if we find a comment which says this, and if the poster of the comment is this Reddit bot that actually classifies it as a Dangonaut. And there are some other minor pre-processing steps here. So the total comments in percent up. So yeah, this is just to sort of revisit what this data looked like when we scraped it. So as you can see, comments come with this string characters, which we don't want. We just want it as a numerical variable so we can manipulate it easier. And the same goes for percent ups. We have these character strings that we don't want. So what we're doing in the pre-processing step is basically converting them by first removing the extra string characters and then casting their types as int.
Okay, so this is an important thing that they're doing now, right? They had a feature that had a number and some junk, and in order to treat it as a numerical feature, they got rid of the junk. Okay.
Yeah. Any questions?
So something that might be confusing about that data set was we had same values in multiple columns. So that was because there's some redundancy in that data set because all of those rows were referring to the same mean, but a different comment. So here we're aggregating all of them together.
Right. So that's a good point. And the way we aggregate is we use this function in pandas called group by. So actually, if you look at the initial form we got this data in, is all of these rows, all of these 5 rows on display here are actually corresponding to the same post. But we have 5 rows because we have 5 different comments for the same post. And what we do after using this group by is we sort of aggregate the comments together. So we concatenate the documents together into one single document. And by using group by, the entire document, all the comments end up as one row. So this is what the data looks like after our pre-processing. So now you have one row for each data set, for each post, and all the comments are within this comment field.
There's a question, what's the percent ups? Is it upvotes upon upvotes plus downvotes?
The percent, no, that's just upvotes, right? It could be the difference, it could be the delta, but I think it's just the total number of upvotes.
They're asking about percent ups. There's another column that says percent upvotes.
Okay, but I mean, that, like the name suggests, it's just like, you know, percentage of votes that were up, that were positive, as opposed to percentage of votes that were negative. So if it's 91% upvotes, that means, you know, if 100 people engaged with this post, 91% of them upvoted it and 9% downvoted it.
Can you explain why you have the dot reset index where you're doing the percent ups thing?
Yeah, so what that does basically is, had we not done that, this ID column on which we grouped by would have ended up as an index here. So reset index just sort of again remakes it as a column just like the other columns. Because I think we down below in the code we'd be using it as a simple column. But that in this particular piece of code, I think that's not super important right now. So we could have gone without reset index presumably as well. But reset index is nice in the sense that, you know, you restore your original index and you have the column on which you grouped by the separate column, just like the other column.
So you don't want it to be ID. That shouldn't be your index. So that's why you did dot reset index. So now it's just like integers, I guess, numbers.
Yeah. Okay. Any other questions? Any other questions regarding how we used group by? The group by in pandas is very similar to how group bys work in SQL.
I have a question. Mm-hmm. So usually pandas is very slow with the apply function. Is there something which we can do to speed it up?
I mean, apply is actually much faster than if you loop over the entire data frame. I think the speed of apply really depends on what you're doing within these lambda functions or within the function that you pass.
Yeah, I meant apply with lambda for each row probably.
Right. So to be honest, in my experience, apply is not really that slow. it's definitely much faster than a for loop or a while loop. So can you maybe talk more about like, in what instance did you find it slow?
I mean, when it has a lot of rows and you want to do some row-wise operation, it just takes a lot of time.
One thing I found helpful in that case is if your column tends to have repetitive values, you could just do a dot value counts, and then for every unique value, just do the computation once and then store it in a dictionary and call that with an apply.
Yeah, that makes sense. Okay, thank you.
Any other questions? Okay, so now that we are moving along, now that we have the data set in a more workable form, we're going to try and do some more machine learning on this. And what we are going to try and do is, for classification, we're going to try and predict the Boolean variable DAC, true or false, and for regression, we're going to try and predict the number of upvotes that were given to them.
How many features, again, for these guys, it's probably, the regression is probably going to be most interesting to them. But what kind of, how many numerical features do you have for this?
So numerical features, we have comments, commenters, we have the number of upvotes, we have total comments and percentage of upvotes.
And you're trying to predict what?
We're going to try and predict this Boolean classification variable first, a DANK or not, which is if the post was popular or not, liked or not. And we're going to try and predict the number of upvotes for each post.
Okay. So the dankness is a classification.
Right. So we're going to cover that first. This is sort of what the distribution looks like. So most means here were labeled as dank, and the rest of them are false. So it's uneven, but this is to be expected in any real world data set. You rarely ever have a binary classification case where you have a 50-50 split of true and false classes. Just for exploration's sake, and this is something that you should always do when you're just like exploring the data set. You should make this correlation matrix. So we're just seeing what are the dependencies and the relationships between the variables that we have available to us. And you can see that the number of comments is correlated with the number of commenters, which just goes to show that people tend to comment only once. If there are more comments on a post, then they tend to be by different users. Similarly, if a post has a lot of comments, then it generally has a lot of upvotes as well. There's a correlation coefficient of 0.46 here. But there is a negative correlation here which says the total number of comments is inversely proportional to the number of upvotes. So for posts that are often disliked, people make sure they comment and they express their displeasure at those posts. So it's not that the total number of comments, if you see a lot of comments, then that post is necessarily liked by the community there.
That surprises me somehow, as someone here who did not, so dank is, first of all, dank is considered good. Is this right? I'm now sounding kind of square, but is that right?
It is good, yes. Dank is good.
And okay, so this is interesting, okay? To me at least, okay, that's behavior. What else do I look at this thing? If I take a look at this correlation matrix, one thing I am noticing is a lot of variables that are near zero. The correlations are near zero. What do I expect those correlations to be worth? I expect them to be worth very little to nothing. Okay? So, just from a general classification point or prediction point of view, but keep going.
Right. So just to visualize what these, like if you get high numbers here, what do these variables actually look like? What kind of relationship do they have? We're going to draw a scatter plot for two variables that are highly correlated. These are number of upvotes and total comments. And we're going to do this using a function called scatter from the matplotlib library. It's simple. It just takes two parameters, the variable you want to plot on the x-axis and the variable you want to plot on the y-axis. The remaining parameters have to do with formatting, so you don't have to pay too much attention to that. So this is what the distribution looks like when we plot these two variables, for which we had a high correlation. It was 0.46. So as you can see, most of these points are clustered at the bottom left of this plot. So we're again going to use the log. We're going to log the two variables to see a better spread so we can visualize it better. And this is what it looks like when we log both variables, total number of comments and upvotes. And you can see there's clearly an angle which suggests that the higher the number of upvotes, the greater the number of total comments.
The colors refer to what the dank ones are red and the other ones are blue?
Yeah.
Okay. What does a plot like that tell us about how successful we're going to be telling dank from non-dank? Can anyone look at a plot like that? Are they optimistic about their ability to identify dankness?
From the current visualization, it doesn't look like it, but I wonder what if we transform the dimension or the angle, will we get a different result?
Okay, it looks to me that the dank and the non-dank are occupying the same space. There's not much difference between these distributions. Okay, so think your possibilities of doing this are dim. They may not be dank, but they are dim of separating them. Okay, keep going. Or any questions about that? Do people see kind of what my thinking is? Learning how to read these things is kind of an important way of understanding the world. Okay, keep going.
Right, so what Steve is saying is if these blue points and these red points were well separated, then that would give us hope that these variables could be used to very accurately predict the Y variable, which is dank or not here. But because there's so much overlap, then we're sort of not so hopeful that these variables would be of much help. But let's see.
How much time do we have? I guess around 12 minutes.
You have a little bit more than 12 minutes. Yes.
I'll try to speed up. Because we have also.
It's important that you show them eventually the linear regression. That I think they want to see.
So again, so we did cover logistic regression. We touched on it previously. We did this here as well. The simplest thing to do often when you're doing classification is to use logistic regression. And so we are doing that. And again, for X variables, we're just using total number of comments and upvotes. And the Y variable in this case is the binary variable called dank. We're doing it. And again, the test size in this case, Charlotte had it set to 0.3. I have it set to 0.2, which means 80% of the data is going to be used for training and 20% is going to be used for testing. And this is what the classification results look like. Now, you might think that these are actually good classification results, but if you pay a little more attention, you'll see that actually for the minority class, it's not doing so well. It's only able to accurately classify 3% of the classes of the posts that were labeled as not tagged. So it's doing so what it's doing essentially is it's classifying almost everything as tagged, because that was the majority class. And this is something that you would come across again in balanced classes. But this only goes to show that these features might not be the best features for this task, for trying to predict this.
When I see what precisions of 0.5, when you're doing a binary class, what problem can you do a classification of binary classification and get an accuracy of 0.5? If you want to predict a coin flip, okay, that's a 0.5% precision or accuracy. So this is again showing me that this is bad, right? That all it's doing is saying I'll use the more popular class, and I'll get that right. How often that one is more popular? Okay.
Right.
Move on. Let's move on.
So we're going to use a different set of features, and we're going to use basically the comments, and we're going to use these comments in a way similar to how we did it previously in the TED Talk data set. We're going to vectorize these text features into into numerical features using something called count vectorizer. This is not too different from part one encoding. It just basically counts for each word.
It's a more advanced thing, but how did the results change?
So now the results are better. We're doing much better on the minority clause. The F1 score has gone up to 0.39 from 0.09. And we're able to recover back a larger proportion of the minority class.
Okay, so the comments have enough, the comment features have enough, lift to make us do a better job. Okay, good.
And here we're sort of unpacking what the classifier has learned and trying to look at the most and the least informative words that it picked up on. And you can see if the most informative words it has identified are words such as downvote, lost, I don't know if the rest of them make sense, but basically it's saying that these, if it sees downvote in one of the comments, then it's almost sure that the post is not very much liked, is what this is showing. So we have the 10 of the most informative words and we have 10 of the least informative words. And we got this by looking at the weights that were learned by the classifier. So again, if you're doing linear regression, you can look at the weights and see which one is more important than the other based on the absolute value of the weight. Any questions?
Okay. You said you had an example of linear regression?
Yeah, so that's next.
Go do that now.
So Charles is going to cover that. Yeah. Stop sharing.
Yep. So this is the example of predicting upvotes from the total number of comments. So here what we're doing is assigning the total comments to X and the number of upvotes to Y. And we're again calling train test split on this. And we do this in a way similar to how we call logistic regression, just that our Y column is numeric here. So here we're initializing the object by calling this the init function of this, and then the dot fit basically fits the regression model to your X train and Y train. Again, dot predict gives us the predicted numerical values for these, the features within your X test dataset. So if you wanted to take a look at Y pred, it would just be a list of numeric values. And these three functions are inbuilt sklearn things that give you error metrics for your regression. So you would just give it your original test values versus your numeric predicted values from the model. And this gives you the mean absolute error, the mean squared error, and the root mean squared error. So for root mean squared, we're just calling the same function and taking a square root manually. So here we have a plot of the number of comments and the number of upvotes. So there is, it does look like there's a positive relationship between the two, but it's not entirely clear directly from this graph that it's easy to predict upvotes using the total number of comments. We've done the same thing here just on the log scale. So we've taken the log of the number of comments instead of using it directly. So this looks much more cleaner. So it looks like the relationship with log is clearer than the one with number of comments directly. So here we have another example where if you want to fit to a power of
any questions about that? Go back to that just to make sure that they don't, this is, do people see how this linear regression is working and what is going on here? Okay. So at the very least, you guys can now look at this as an example for how you would do linear regression in what you're doing. Okay, keep going.
So we've just combined two different things in the same column. This would be the same as initializing the object first and then calling regression.fit.
In the first plot that you've shown, it doesn't seem like linear regression would work well, but when you do the log thing, then it seems like it should give you a considerably good result. Then how do you normally decide whether to go with linear regression or something else when you start with that?
my answer would be you start to use linear regression because it's sort of a simple method. Okay. Again, the problem here is that the reason you're getting a linear relationship here is because you're trying to predict the log of the upvotes from the log of the comments. Okay. It probably looks a little bit better than if you're trying to predict the number of upvotes. Okay, it's still, it's easier to predict the log of the number of upvotes here than it is the actual number of upvotes. Okay, because it's a power law type of variable. Okay, I don't know if that answers your question or not.
So when you're playing around with the data set, you can explore different powers of that variable. So we've tried to do that here, especially in cases where variables like area are involved. Squaring it might help you get better predictive power. So here what we've done is for every power from 2 to 20, we're applying that to the total number of comments and storing it as a separate column. So you can see here that you have the original total comments as one column, and then different powers as more columns included in the data set. And then we're trying to fit this based on all of these columns together. So the fit looks something like this, and we're plotting it only against the initial column and not everything together. So this is a function of 20 columns plotted as a function of the original number of comments.
Okay, what she has done here that may be interesting to you is that she is and we will talk about eventually, she is using linear regression. She has added nonlinear powers of her feature variables to the data set, like the square, like the cube, and then fitting a linear function in these nonlinear variables. She's using linear regression to plot a higher order polynomial. Okay, that's what she is kind of doing. That is kind of interesting here. Now going to 20 powers is pretty ridiculous, which is why it's moving around. The thing that her polynomial is moving around like something crazy. But perhaps having some nonlinear components like the square, like the square root of the variable might make for a more interesting or more powerful feature. Okay, clearly the log made a more powerful feature. Okay, any questions about that? So some of the complaints, again, one of you was complaining about linear regression. How do I know to use a more powerful algorithm? Maybe what you need sometimes are more powerful variables and features, and there's nothing wrong with the linear regression. Okay, and that's kind of what she sort of is doing here, although I don't like the 20 dimensions.
Yeah, that's something else we wanted to cover. So if you do have a lot of variables in your data set, you could use regularization to limit either the coefficients or the number of features that your model uses. So we have two variants here. Ridge, what it does is it puts a constraint on how big the coefficients per feature can get. And Lasso puts a constraint on the number of features that your model can use. So the way we've used them is the same as we use regular linear regression. You just initialize the object, call .fit, and then .predict.
Okay, so this is now interesting. She is now saying that she set up her data set. Originally, it was only one variable, and so there was the dumb green fit, right? Then she blew it up to a 20-dimensional data set. And there was the dumb 20-dimensional fit. That was the red one. Then she used this technique called regularization to throw out variables that really weren't contributing very much. And she got a nonlinear fit in blue that is much more sensible. Okay? So that is a relatively happy ending, and maybe this looks like an even happier ending. Okay, now her fit is the blue curve, which is smooth. She did a different form of regularization. Okay, and that maybe looks like the best of the bunch of these fits. Any questions about that? Again, we will talk about linear regression later in the semester, but those are some of the considerations that might apply if you have a large number of variables. Okay? Any questions?
So similar to logistic regression, you can also access the coefficients per variable by doing .coef, and that just returns a list of coefficients assigned to each of the columns in your training set.
Another thing I think I should add is, and this is relevant for your assignments, is like one major takeaway from this is like visualize your variables, especially for your assignment. If you're trying to predict sales, make a scatter plot of the sales variable that you're trying to predict with all the features you have. Also compute that correlation matrix to see what kind of relationships exist. And then you can decide if you need to use linear regression or a more advanced model, or if you need to log the variable or not. So visualizations are very important to gain an insight into what is actually going on in your data set and what your models are actually doing.
If there's no questions, we can just quickly cover clustering as well. So this is when you don't have a Y variable and you're trying to group your data into different clusters without really having a column to predict, just based on the features of the data itself. So here we have the percentage of upvotes and the sample number of commenters, and we're trying to group them into 5 clusters of their own. So this is also similar to the way we call logistic regression. It's just that here, since we don't have anything to fit on, we just call fit predict on X directly. And it assigns a label to each of these points depending on which group it belongs to.
Okay, we will talk about clustering also later in the semester. Any questions about that?
Yeah, could you go back to last graph? Yeah, this one. So the X is 0, 1, 2, and the Y is like power to 10,000 of times. Would you get concerned that this is not a match if you plot it in the same scale? Would the graph become unrecognizable?
Okay, what I guess your concern is that again the x-axis is in log scale. What you're trying to predict here, is it in log scale or not?
I think in this case it's not in log scale.
Okay, so here there is okay, so here you're trying to predict it
the number of upvotes directly from the log of the number of comments.
It's not clear to me that actually, if you were trying to predict the number of upvotes, does the log work better than the actual number of upvotes?
I think the log to log was working better. We didn't really compare the log to Y direct.
Log to log. Here, what you see is the y-axis variables are he's concerned big, but I'm also going to argue maybe power law distributed. The x-axis, the number is no longer power law distributed. Okay. You know, if I were looking at this thing, I would probably, you know, having the features be the log of the number of comments, that's a useful feature. Maybe the number of comments, rather than having the log of the number of comments raised to the 20th power, which is one of your features. A better one would probably be the number of comments itself, right?
Yep.
Okay.
Could it be better to have log of upvotes as well as log of number of comments in this case with the power law thing?
Okay, trying to predict the number of upvotes from the number of the log of the number of upvotes would be a bad idea. because you need to know, one, it's like trying to predict someone's height in meters given their height in inches. It's deterministic. But on the other hand, it might be more in the case of, I'd have to look at the distributions of what your variables are to try to figure out what you really want to be predicting. Okay? If you're trying to predict a power law thing, it might very well be trying to predict, better to predict the log of the y variables, okay, rather than the original. Okay, this is something to play around with once you have simple models. Again, I encourage you to start out by doing simple things. Predict the y given your x's. Then, see, once you get some ideas with that, playing around with normalization, playing around with these features, I think you will see something that will give you a better result. And that's kind of for an assignment like what you got, I would encourage you that kind of exercise. And we will talk more about these things with time, okay? Any questions? Any other questions for Fahad or Charuta? Okay, how many people found their presentation dank? Okay, am I getting dankness? Okay, okay, so there's it looks like you're becoming dank. Okay, anyway, thanks for your attention. Next class we will talk more about what you call it. We'll talk about data cleaning, which is an important part of this thing, and I will encourage you to get playing with the data set if you haven't already done so, and it will be good for you. Any questions? If not, thanks for your attention, and I will see you next time. And thanks to Charuta and Fahad.